So this is number 30 for chapter 5, and it asks you to find the velocity at point B and the velocity at point C. So what I did first was I found the total energy, and I did that by finding the initial energy at point A, and since the only force acting on the ball at point A is gravitational potential energy, I did equals mgh, which equals 5.00 kilograms times gravity times the height, which is 5 meters, and that turns out to be 245 joules. So that and since energy is conserved throughout this whole diagram, to find the velocity at point B, I did the initial energy equals 1/2 mv squared kinetic energy plus mgh, and that number goes here because energy is conserved, and 5 kilograms times v squared plus 5 kilograms times gravity times the height at point B, so 3.2 meters, and v squared equals 35.28, which means v is approximately 5.94 meters per second. And to find the velocity at point C, you do the same thing, but with the height for point C, which is 2 meters. So you'd get 245 joules equals 1/2 times 5 kilograms times v squared plus 5 kilograms times gravity times 2 meters. So v squared would turn out to be exactly 58.8, and velocity at point C is 7.67 meters per second. And for part B, they want you to find the gravitational potential energy they want you to find the net work done by the force of gravity in moving the bead from A to C. So you do the gravitational potential energy from point A to C, and to find that you would just do the gravitational potential energy at point A minus the gravitational potential energy at point C. So UG of A, I don't know if that's the correct notation, but that is the notation I used. At A minus mg, the height at point C. You can factor out the mg and just do 5.00 kilograms times 9.8 meters per second squared, and then times the height at point A minus the height at point C. So 5 minus 2 and that equals 147 joules. Okay, that's how you do everything.